Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry O-Levels multiple choice, paper 12 from October-November 2021. You can go to any particular question by following timestamps given in the video description. Let's start.
Question 1. In titration, 25 cm³ of aqueous sodium hydroxide is transferred into a conical flask. A few drops of indicator are then added. Dilute hydrochloric acid is then added to the flask until the endpoint is reached. Which pieces of apparatus are used to measure the volume in this experiment? As we have titration experiment, so in titration we have burette in which acid is added, and we have conical flask in which alkali is added. So sodium hydroxide is taken in conical flask, but what are we going to use to measure sodium hydroxide? First option is beaker. Beaker is inaccurate, so we do not use beaker for accurate measurement. Pipette is accurate. On acid side, we have two things. One is pipette, one is burette. Pipette can be used to measure acid, but in titration we are going to use burette as both the measuring agent and the apparatus in which it is collected. Correct answer is therefore B. Question 2. A student follows the rate of the reaction between marble chips. We have calcium carbonate and dilute hydrochloric acid. The reaction is given. Calcium carbonate reacts with hydrochloric acid to form salt, carbon dioxide and water. Which diagram show apparatus that with a stopwatch is suitable for this experiment? In this reaction we are studying the rate of chemical reaction. Now rate of reaction can be determined by measuring the change in mass per unit time or change in volume per unit time. For mass we can use calcium carbonate as it is solid, so we can measure the change in mass. For volume we can use amount of carbon dioxide that is formed. In first experiment we can see we have marble chips which is calcium carbonate. It reacts with hydrochloric acid. Now gas is formed and this gas is collected using measuring cylinder. We also have a stopwatch in each experiment, so therefore we can measure the change in volume per unit time or volume of gas produced per unit time. This will give us the rate of the reaction, so therefore experiment 1 is correct. In experiment 2 we have marble chips that reacts with hydrochloric acid and there is loose cotton plug. So what will happen that when carbon dioxide is formed, it will be released from this plug. So we can measure the change in mass using the given balance. So it is the loss of mass of calcium carbonate per unit time. So experiment 2 is also correct. This is the third experiment. In this experiment we have hydrochloric acid present in the burette which will be poured dropwise, and we have marble chips present. The balance is not given, so we cannot measure the change in mass. Also the gas which is formed, it will escape as this is open. So we can neither measure the change in mass nor measure the change in volume of carbon dioxide, so therefore third experiment is incorrect for measuring rate of reaction. As experiment 1 and 2 only are correct, so therefore answer is B. Question 3. Pure oxygen is needed by many industries. How is pure oxygen obtained in large amounts for such uses? Part A, by decomposition of calcium carbonate. Now we can write equation for that. Whenever calcium carbonate is heated, what happens that it breaks down into calcium oxide and releases carbon dioxide gas. Now oxygen is not produced by this process, so therefore A is incorrect. In B, we can see by decomposition of hydrogen peroxide. Hydrogen peroxide is H2O2 and it can be decomposed to form water and release oxygen gas. Now this oxygen produced, it is not in larger amounts, and again we need larger supply of hydrogen peroxide, which is very expensive. So therefore this method is not used in industries. C is by filtration of liquid air. Now filtration can only remove solid particles. It cannot separate oxygen from the mixture. So therefore C is also incorrect. Part D is by fractional distillation of liquid air. Now fractional distillation is the separation on the basis of boiling point. So we can separate oxygen based on this experiment. Oxygen is 21% in air, so there is quite a large quantity of oxygen that can be obtained from fractional distillation of liquid air. Correct answer is therefore D. Question 4. An impure sample of compound X has a melting point of 120 degrees centigrade. X is purified and its melting point is measured again. Which row is correct? We have to find out the method of purifying and we have to find out the melting point of pure X. To solve this question, you should remember this, that impurities, they always decrease melting point. And impurities, they increase boiling point. In this question, they have given melting point. So if 120 degrees centigrade is the melting point of impure sample, and we know that impurities decrease the melting point, so therefore this one is decreased value. So for pure sample, the value must be greater than 120 degrees centigrade. So we can say that 120 degrees centigrade is for impure sample. So for pure sample, it must be greater than 120 degrees centigrade. So it can be 125, it is not 115. Second thing is to find the method of purifying X. Now as X is impure sample of solid, so therefore we cannot use distillation, because distillation can be used only to separate liquids from solids or liquids from liquids. Now we have crystallization. Crystallization can be used, in which we are going to make a solution and then crystallize the pure sample. It will form crystals and they can be separated. So therefore correct answer is part C. Question 5. When aqueous sodium hydroxide is added to compound X, a red-brown precipitate is formed. When dilute nitric acid followed by aqueous barium nitrate is added to aqueous compound X, a white precipitate is formed. What is X? Now in the given statement, they have given two different tests. First one is the test for iron plus 3 cation. Second one is the test of sulfate anion. In the given options, we have two different cations. One is chromium 3+, second is iron 3+. Now chromium 3 plus when added to aqueous sodium hydroxide, it forms grey-green precipitate. While if iron plus 3 is present, it reacts with sodium hydroxide to form reddish-brown precipitate. So first part is iron. Now looking at the second thing, we have sulfate and we have chloride. For sulfate, when barium nitrate is added, what will happen that barium reacts with sulfate ions to form a precipitate of barium sulfate. And this is white in color. While for chloride, it does not form a white precipitate, it will form barium chloride, which is soluble. So it is sulfate, not chloride. Correct answer is therefore D. Question 6. An aqueous solution of zinc chloride is tested by adding reagents. Which observation is correct? First is the reagent added to zinc chloride and second is the observation. Part A. Acidified aqueous barium nitrate and forms a white precipitate. Let's add barium nitrate to zinc chloride. We can see we have barium nitrate which is soluble, so it is aqueous. It can react with zinc chloride which is also aqueous to form barium chloride and zinc nitrate. As both barium chloride and zinc nitrate are soluble, so therefore we cannot see a white precipitate. So option A is incorrect. Part B. Aqueous ammonia and it forms a white precipitate soluble in excess of the reagent. Now in aqueous solution of zinc chloride, we have two ions, one is zinc plus 2 and one is chloride negative. Now in the test for cations, if we add aqueous ammonia in zinc plus 2 ions, what will happen that it forms a white precipitate of zinc hydroxide which is soluble in excess of the reagent. So option B is correct. Option C. Aqueous sodium hydroxide and it forms a white precipitate insoluble in excess of the reagent. Now aqueous sodium hydroxide, it will form zinc hydroxide with zinc chloride and zinc hydroxide is white precipitate. So first part is correct that it will form a white precipitate, but second part it says insoluble in excess of the reagent. This is incorrect because zinc hydroxide is soluble in excess sodium hydroxide. Part D, we have powdered copper which if added to zinc chloride it forms a grey precipitate. Let's see this one. As copper is less reactive as compared to zinc chloride, so therefore this reaction will not occur. The only correct option is part B. Question 7. A sample of gas is released at a particular point in laboratory. A detecting device is placed 10 meters from the point where the gas is released. This device detects and records time when the concentration of gas is 10 molecules in every million molecules of air. The experiment is carried out with two gases at different temperatures. In which experiment was the time recorded by the detector Gray test? Now this experiment is done to actually find out the rate of diffusion. Slower gas will diffuse slower, so therefore the time will be Gray test. So we have to find the gas that diffuses slow. We have two gases, one is SF6, one is CO2, and we have two different temperatures, one is 20 degrees centigrade, one is 40 degrees centigrade. Now you should remember that diffusion is inversely proportional to molecular mass, and diffusion is directly proportional to temperature. This is because when temperature is increased, the kinetic energy of molecules increases and diffusion also increases. While greater MR means that the molecule is heavy, so therefore heavy molecules have slow rate of diffusion. Let's find the one that is taking the greater time. So we have SF6 CO2. In SF6 we have 1 sulfur, 6 fluorine atoms. In CO2 we have 1 carbon, 2 oxygen atoms. The atomic mass of sulfur is 32. Plus we have 6 fluorine atoms. For 1 fluorine it is 19, so 19 into 6. It comes equal to 146 for SF6. In CO2 we have carbon, which is 12. We have 2 oxygen, 16 into 2 becomes 32. So 32 and 12, it becomes 44. So we can see that CO2 will diffuse faster as compared to SF6. Second is the temperature. We need the temperature in which time taken is greatest. So therefore diffusion is slow. So at 20 degrees centigrade, diffusion will be less. Correct answer is therefore A. Question 8. The table shows data for some particles. We have sodium ion, we have fluoride ion, magnesium ion. They've given the proton number, nucleon number, protons, neutrons and electrons. What are the value of W, X and Y? This one is W, this one is X, and this one is Y. We can find number of neutrons by subtracting nucleon number with proton number. So neutrons is equal to nucleon number minus proton number. So it is 23 minus 11. It comes equal to 12. So W is 12. Then for X, we have to find the number of electrons. As this is ion, so we know that it must have gained electron because fluorine is from group 7 of the periodic table. It is a non-metal, so therefore non-metal gains electrons. And as there are 7 electrons in the outermost shell, so it needs one more electron to complete octet. So therefore fluorine will gain 1 electron. If proton number is 9, then number of proton is 9 and number of electrons must be 9 plus 1, which is equal to 10. And this is for fluoride ion. Third part is magnesium ion. Magnesium belongs to second group of the periodic table. Let's look into this one. We have 12 proton number, so therefore it means that the number of proton is 12. So Y is 12. Correct answer is therefore C. Question 9. A covalent compound P has the empirical formula CH2O. Which structures represent P? They have given different compounds. Let's find the number of carbon atoms and hydrogen and oxygen. In first one we have 1 carbon C, then we have 2 hydrogen atoms H2 and 2 oxygen atoms O2. The ratio is already simplified, 1:2:2, 1 for carbon, 2 for hydrogen, 2 for oxygen. So it cannot be simplified further. So empirical formula will be CH2O2. A is incorrect. For B, we can see we have 2 carbon atoms, 4 hydrogen atoms and 2 oxygen atoms. Now we can simplify 1:2:1. So it becomes CH2O. So B could be correct option. Let's look into the third part. We have 2 carbon atoms, 4 hydrogen atoms and 1 oxygen. So as the ratio is 2:4:1, so it is already simplified. So this is the empirical formula. It is wrong. Part D, 3 carbon atoms are there, 6 hydrogen atoms are present and 2 oxygen atoms. This cannot be simplified further because we have odd number present with an even number. So therefore this is the empirical formula. It is also incorrect. Correct answer is therefore B. Question 10. Which statement about the structure or bonding of metals is correct? Part A metal lattice consists of negative ions in a sea of electrons. This one is incorrect because metal consists of positive ions in a sea of electrons. Part B, electrons in a metal move randomly through the lattice. This is true because electrons are free to move, so they can move freely wherever they want. Part C, metals are malleable. This is true because the ions present are mobile. Now the ions, which are positive ions, are actually fixed in the position, therefore the metals have fixed shape. And metals are malleable because the atoms present, they can slide over each other. So therefore this statement is wrong. Part D, the ions in a metal move when positive and negative electrodes are attached. Now when current is passed from positive and negative electrodes, it is the electrons that start to move, not the ions. Correct option is therefore part B. Question 11. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? We can use the formula for mass. We can see mass in grams is equal to number of moles into mR. Now we have chlorine gas. Chlorine gas is Cl2. There are 2 chlorine atoms present in one molecule of chlorine gas. So the molecular mass will be 2 into 35.5, which is equal to 71. As we have 2 moles, so we can put 2 moles instead of moles, and mR is 71. So 71 into 2 is 142 grams. Correct answer is therefore D. Question 12. When gases react, the volume of gaseous reactants may be different from the volume of gaseous products. For which reaction is the percentage change in the volume of gas largest? Assume each reaction goes to completion. Now we can find the volume change by subtracting the volumes on the reactant side and on the product side. So we can say that change in volume it is equal to the volumes of reactants minus volume of products. As in the question or in the statements, they haven't given the volume, they have only given the number of moles. So for gaseous equations, you can always assume that mole ratio is similar to volume ratio. So we can say that for 2 moles of SO2, we can write 2 volumes of SO2. It reacts with 1 volume of oxygen to form 2 volumes of SO3. Now finding change in volume, volume of the reactants is 2 plus 1, 3 minus volume of product, it is 2. So we have a change of plus 1. So it means that 1 volume decreases from reactants to products. In part B, we have 2 plus 1, 3 moles or 3 volumes on the reactant side, and 2 plus 1 3 volumes on the product side. So there is 0 volume change, which means neither the volume has increased nor it has decreased. In part C, we have 1 plus 3, 4 volumes on the reactant side and 2 volumes on the product side. So we can see that 2 volumes have decreased. Similarly, in part D, we have 9 volumes on the reactant side and 10 volumes on the product side. So the change is -1, which means that 1 volume has. Among 1, 0, plus 2 and -1, we can see that this is the largest change in the volumes. So correct answer is part C. Question 13. Sodium carbonate, it reacts with dilute hydrochloric acid. This is the equation. Salt, water and carbon dioxide is formed. A sample containing 0.08 moles of sodium carbonate is added to solution containing 0.1 moles of HCl. Which volume of CO2 is produced? Measured at room temperature and pressure. According to balanced equation, 1 moles of sodium carbonate, it reacts with 2 moles of HCl to form 1 mole of CO2. Now, product always depends on the limiting reagent. Let's find which one is the limiting reagent among these two. As we have sodium carbonate and HCl, according to balanced equation, we have 1:2. Now, the moles of HCl is 0.1 moles. So if 1 mole of sodium carbonate is needed for 2 moles of HCl, then for 0.1 moles of HCl, how much sodium carbonate will be needed? We can cross multiply and find the answer. X will be equal to 0.1 divided by 2. It comes equal to 0.05 moles. So 0.05 moles of sodium carbonate will react with 0.1 moles of HCl. Now, they have given 0.08 moles of sodium carbonate. It means this one is more than required. So, sodium carbonate is in excess. We can find the excess amount. Given moles is 0.08. Required moles is 0.05. So 0.03 moles will be left behind. It means that HCl is the limiting reagent and sodium carbonate is the excess reagent. Now, amount of product always depends on the limiting reagent, so we can find the ratio between HCl and CO2. According to balanced equation, 2 moles of HCl form 1 mole of CO2. Now, they have given 0.1 moles of HCl, so we can find number of moles of CO2. Let's cross multiply. So 0.05 moles of CO2 is formed. Now we can change moles to volume. As volume is given in decimeter cube, so we can use the formula. Volume in decimeter cube is equal to number of moles multiplied by 24 decimeter cube. So we have 0.05 number of moles, so 0.05 into 24, it comes equal to 1.2 decimeter cube of CO2. As we can see, among the option, B is the correct answer. Question 14. Which statement about the electrolysis of solutions is correct? They have given the different options. Part A. During electrolysis of concentrated aqueous sodium chloride solution, hydrogen is produced at the cathode. Let's look into this one. We have concentrated aqueous sodium chloride. So in concentrated aqueous sodium chloride, we have Na positive, we have Cl negative, we also have H positive as it is aqueous solution, and we have OH negative. So cations move towards cathode. This one is cation, this one is also a cation. Among these two, in the discharge series, we know that H plus discharges more easily as compared to sodium. So therefore H plus will move towards cathode, it will gain electrons and form hydrogen gas. So A is correct. Part B. During electrolysis of dilute sulfuric acid, oxygen is produced at the cathode. In dilute sulfuric acid, we have H positive ions, we have OH negative ions from water, we also have sulfate ions. Now cation is H positive and cation moves towards cathode. H positive will move towards cathode, gain electrons and form hydrogen gas. So oxygen gas is not produced, it is hydrogen gas that is produced at the cathode. Option C. When aqueous copper 2 sulfate is electrolyzed, the reaction taking place at the cathode is this one. Let's see what ions are present in aqueous copper 2 sulfate. We have copper 2 positive, sulfate 2 negative, H plus as it is aqueous, OH negative is also present. So cation moves towards cathode. Among copper and H positive, copper is easily discharged as compared to H positive because it is low in the discharge series. So we can say that Cu2 positive, it will gain 2 electrons and deposit as copper. So in this equation, the charges given is incorrect, so therefore C is wrong. Part D. When aqueous copper 2 sulfate is electrolyzed using copper electrodes, the mass of the anode at the end of reaction will be greater than at the beginning. Now you should always remember that anode always dissolves in the solution of its own ions. So as we have copper electrodes and copper electrode will be dissolved in copper 2 sulfate, so therefore the mass of anode will decrease. So this one is wrong. Among these four, correct option is A. Question 15. The apparatus shown is set up to plate a steel key with copper. We have this copper and we have steel key that is attached at the electrodes. The solution is of aqueous copper 2 sulfate. The key does not get coated with copper, which change needs to be made to plate the key. In this experiment, we can see that the copper is electroplated on the key, so therefore copper must be attached to anode. And anode is positive electrode or positive terminal of battery. Because anode always dissolves in the solution and then it gets deposited on the cathode. So these should be reversed. Let's look at the options. We have A, which says increase in concentration of the aqueous copper 2 sulfate. This will not result in the electroplating because the terminals are reversed. Part B is increase in voltage. It is also incorrect. Part C is that the replace solution with dilute sulfuric acid. This is also incorrect because we need the solution of copper in order to electroplate copper. Part D, reverse electrical connections. This one is true. Correct answer is therefore D. Question 16, the equation shows the reaction of glucose with oxygen. We can see glucose, it reacts with oxygen to form carbon dioxide and water. Which statement about this reaction is correct? Part 1, it says A, it can occur in the dark. Part B, it is endothermic. Part C, it needs chlorophyll as catalyst. Part D, it occurs in plants but not in animals. So now we can see that this is the respiration equation in which glucose converts into energy along with CO2 and H2O. So yes, respiration does not need light. It is photosynthesis that needs light, so A is correct. Part B, it is endothermic as energy is also released in this equation which can be used to do work. So therefore this is not endothermic, this is exothermic reaction. Part C, it needs chlorophyll as the catalyst. Now chlorophyll is used in photosynthesis and photosynthesis is the reverse of this reaction. In photosynthesis, 6 molecules of CO2 and 6 molecules of water, they react in the presence of chlorophyll to form glucose and release oxygen. Part D, it occurs in plants but not in animals. No, this is also incorrect because it can occur in animals too. It does occur in human bodies. Correct option is therefore A. Question 17, the energy profile diagram of a chemical reaction is shown. This is the energy profile diagram. These are the reactants and this is the product. Which statement is correct? Part A, the reaction is exothermic. As we can see that reactants are at lower energy as compared to products. So it means reactants have absorbed energy in order to convert into product which has greater energy. So this reaction is not exothermic, it is endothermic. B, X represents the activation energy for the reaction. Now activation energy is the energy that is needed by the reactants to convert into this transition state. So from this to this is the activation energy and it is represented by X. So therefore this statement is true. Option C, Y represents delta H for the reaction. Delta H is the enthalpy change and it is the difference of energy between products and reactants. So energy of products minus energy of reactant, it gives delta H. So the arrow should be here, energy of product and the energy of reactants. Y is not that one. D, Z represents the energy given out as the reaction proceeds. Now as this reaction is endothermic, it is not exothermic, so energy is not given out. Energy is actually absorbed as the reaction proceeds. So the arrow should be like this. So D is incorrect. Correct option among these is B. Question 18, the equation shows the reaction for the manufacture of ammonia. We have nitrogen gas that reacts with hydrogen gas to form ammonia gas. Which change will decrease the activation energy of the reaction? Part A, addition of a catalyst. Now this is true because catalyst decreases the activation energy of the reaction and now the reaction will become faster. So option A is correct. Option B, decrease in temperature. Now decrease in temperature does not decrease the activation energy, it decreases the average kinetic energy of the molecules. Third one is increase in concentration. Concentration does not change the activation energy, only catalyst can decrease the activation energy. Correct option is part A. Question 19. The apparatus shows a method of following the rate of the reaction between magnesium carbonate and dilute nitric acid. Carbonate plus acid, it forms salt, water and releases carbon dioxide gas. It can be measured using this gas syringe. This is the apparatus. We have flask, we have magnesium carbonate along with acid. The graph shows the volume of gas collected against time. This is the graph. On y-axis we have volume of gas collected and on x-axis we have time. In the start the volume was greater and slowly the reaction goes to completion and no more CO2 is formed. Three statements are made about the experiment. Number 1. The mass of the flask and its contents decrease as the time increases. As we note that the reaction is taking place and volume of CO2 it is collected, so therefore the mass of the flask and its contents will decrease with time. Number 2. The rate of the reaction decreases as time increases. This is also true, as we can see from the graph. Steeper the graph, greater will be the rate of reaction, but we can see that slowly the steepness becomes less and it becomes straight line. So the rate of reaction decreases with time. Part 3. The reaction has finished after 4 minutes. As we can see that after 4 minutes the line is straight line. So therefore it means that the reaction has completed, as no more volume of carbon dioxide is being formed. This is also true. So as all three statements are true, therefore answer is A. Question 20. Aqueous bromine is added to aqueous sodium chloride. Which statement is correct? Part A. Bromine is oxidized and chloride ions are reduced. Now we can see that in the reactivity of halogens, the one at the top is more reactive as compared to the one at the bottom. So now we can say that chlorine can replace bromine, but bromine cannot replace chlorine because bromine is less reactive than chlorine. It says bromine is oxidized and chloride ions are reduced. Let's write the equation. We have NaCl plus aqueous bromine. Now as the reactivity of bromine is less than chlorine, so it is unable to displace that and no reaction will occur. So A is incorrect. Part B. Bromine is reduced and chloride ions are oxidized. Again, as this reaction does not occur, so no reduction and oxidation takes place. C. Neither oxidation nor reduction takes place. That is true statement. D. Sodium ions are oxidized. Again, this is incorrect. Only one option is correct, and that is C. Question 21. Which statement is correct for all reversible reactions that have reached dynamic equilibrium? Part A. Introduction of a catalyst changes the position of equilibrium. Now this is incorrect because catalyst does not change the position of equilibrium. Catalyst only reduces time to attain equilibrium. Part B. The number of moles of products equals the number of moles of reactants. Now this is not true for dynamic equilibrium because equilibrium can be established at any ratio of number of moles. It is not necessary 50-50. It can be any ratio between reactants and products. So therefore this statement is incorrect. Part C. The rate of forward reaction equals the rate of reverse reaction. This is true statement. As the rate in both forward and backward reaction become equal, the equilibrium is called dynamic equilibrium. Part D. When the reaction reaches the position of equilibrium, the reaction stops. This is incorrect because the equilibrium is dynamic in nature, which means that it is continuously moving in forward direction as well as backward direction. So correct option is part C. Question 22. Which statement about acids and bases is correct? Part A. A 0.1 mole per decimeter cube solution of ethanoic acid has a higher pH than 0.1 mole per decimeter cube solution of hydrochloric acid. Now pH, it depends on the concentration of H positive ions. So greater the value of H positive ions, lower will be the pH value. And we can see among these two acids, ethanoic acid, which is CH3COOH, it is weak acid as compared to HCl. This is because in ethanoic acid, all molecules are not ionized. The reaction goes to equilibrium. It means that the molecules of the reactant are still present in the solution. While for HCl, all the molecules, they are converted into H positive and Cl negative. So we can say that the concentration of H positive is quite high in HCl as compared to CH3COOH. So therefore pH for HCl will be lower. So solution of ethanoic acid will have higher pH than HCl. This is true statement. You should also remember that lower pH means stronger acid. Part B. All bases dissolve in water to produce OH negative ions. Now this is not true statement because let's suppose we have copper oxide. Copper oxide is a base, but it does not dissolve in water and therefore does not form OH negative ions. Part C. Bases react with nitrates to produce ammonia. Now it is not actually all the bases, it is only sodium hydroxide, which is an alkali. It can react with nitrates to produce ammonia. Part D. Oxides of metals are always acidic in character. Metal oxides are usually basic in nature, they are not acidic. For example, we have sodium oxide. It can react in water to form sodium hydroxide, which is alkali or base. So therefore this is basic character, not acidic. Correct option is therefore A. Question 23. Which compound can be formed by precipitation? Now in precipitation method, insoluble salt is formed, which is in the form of precipitate. And from solubility table we know that all sodium salts, all potassium salts, all nitrates are always soluble. This one is sodium salt, so it is soluble. This one is potassium salt, so it is also soluble. This one is a nitrate, so therefore this is also soluble. So the only one which is insoluble is lead sulfate. So therefore lead sulfate is the only salt that can be prepared by precipitation method. Question 24. Which methods could be used to make a pure sample of copper 2 sulfate? Now copper sulfate is a soluble salt. So therefore soluble salt cannot be made by precipitation. Precipitation can only make insoluble salts from two soluble solutions. Let's look at other options. First one is acid plus metal carbonate. Let's suppose we take sulfuric acid and we react it with copper carbonate. So it can form copper sulfate along with water and carbon dioxide. So we can separate copper sulfate from H2O by crystallization. Part 2. Acid plus metal oxide. Let's take sulfuric acid and we have metal oxide, for example copper oxide. So it is acid base reactions which forms salt, which is copper sulfate along with water. Again copper sulfate is soluble, so therefore it can be separated from water by crystallization. Part 3, acid plus metal. Acid plus metal gives salt and hydrogen. Let's suppose we have acid H2SO4, metal which is copper. Now the reactivity of copper is very less, so therefore we cannot use this method to form copper sulfate. Option 1 and 2 are correct, so therefore answer is A. Question 25. Ammonia is made by a reversible reaction. This is the reaction in which nitrogen gas reacts with hydrogen gas to form ammonia. Enthalpy change is negative, which means it is exothermic reaction. A chemist investigates how the percentage of ammonia at equilibrium changes with pressure. The experiment is carried out at 250 degrees centigrade and 350 degrees centigrade. Which graph shows the chemist results? First thing is pressure. Now pressure depends on the number of moles. If we increase pressure, the equation of equilibrium always moves from greater number of moles to smaller number of moles. Let's look into the volumes. We have 1 volume of nitrogen, 3 volumes of hydrogen. So we have 4 moles on the reactant side, 2 moles on the product side. So by increasing pressure, the equation will shift in the forward direction and more ammonia is formed. So we can say at higher pressure, we have more percentage of ammonia. Second thing is the temperature, as the reaction is exothermic. So for exothermic reaction, if you increase the temperature, the reaction moves in the backward direction. So now what will happen is that for more percentage of ammonia, we should use less temperature. We can say at lower temperature, the reaction will move in the forward direction because the reaction is exothermic, so we have more percentage of ammonia. Let's look into the options. In A and B, we can see that the percentage of ammonia, it increases at equilibrium by increasing the pressure. While in C and D, we can see that the percentage of ammonia at equilibrium, it decreases with increase in pressure. So C and D are incorrect for pressure. Among A and B, we can now see that at lower temperature, more percentage of ammonia should be present. So in this one, at higher temperature, more percentage of ammonia is present, which is wrong. In B, we have more percentage of ammonia at low temperature, which is 250 degrees centigrade. So B seems to be the correct option. Answer is therefore B. Question 26. Which statement about sulfur dioxide is correct? Part A. It is dissolved in water to make sulfuric acid for car batteries. This is incorrect because H2S2O7 is dissolved in water in order to make sulfuric acid for car batteries. Part B. It is the final product of the contact process. Now in contact process, in first step, sulfur is converted into sulfur dioxide. Then sulfur dioxide is converted into sulfur trioxide. Then sulfur trioxide is converted into oleum and then sulfuric acid is formed. So this statement is incorrect. C. It is used as food preservative. Now sulfur dioxide is acidic gas and it is also antimicrobial. So yes, this statement is correct. Part D. It turns aqueous potassium iodide brown. Now potassium iodide is a reducing agent. Sulfur dioxide is also a reducing agent. So they both cannot react with each other. So therefore this statement is incorrect. Correct option is therefore part C. Question 27. The diagram shows parts of the periodic table. We have W, which is in group 2. Then we have X, which is a part of transition elements. We have Y, which is in group 6. Z, which is in group 7. Which two letters represent elements that can react together to form covalent compounds? Now we know that covalent compounds can be formed between non-metal elements by sharing of electrons. Now W is in group 2 of the periodic table and group 2 is metal, so W cannot make a covalent bond. X is part of transition metals. Again, X does not form covalent compounds. Y and Z, Y is in group 6 of the periodic table. Z is in group 7 of the periodic table. Group 6 and group 7 both can comprise of non-metal elements. So therefore Y and Z can react together to form covalent compounds. Correct answer is therefore D. Question 28. Which statement about some of the elements in periodic table is correct? Part A. The element germanium in group 4 has less metallic character than gallium in group 3. Now as we move in the period, what happens that metallic character decreases along the period. So group 4 is on the right side of the periodic table as compared to group 3. So therefore in group 4 we have less metallic character as compared to group 3. Also metallic character can be defined as the loss of electrons. So ease of loss of electrons means more metallic character, and group 3 element can easily lose electron as compared to group 4. So this statement is true. Part B. Elements in group 5 form ions with a charge of 5 positive. This is incorrect because group 5 elements have 5 electrons in the outermost shell. They need 3 more electrons to complete their octet. So therefore charge will be -3, not +5. Part C. Elements in the same group react in a similar way because they all contain the same number of electrons. Now this statement is wrong because elements in a same group, they do react in a similar way, but they have same number of electrons in outer shell only. Overall the number of electrons is not same, it is different. Part D. Transition elements are given its name as they easily change from solids to liquids. This is wrong because transition elements, the name is given because they have variable oxidation states. Electronic transitions are also easily possible in transition elements, so therefore they form colored compounds. Among these, correct answer is part A. Question 29. These statements are about halogens. Number 1. All halogens are non-metallic diatomic molecules. This statement is correct as we have fluorine F2, chlorine is Cl2, bromine is Br2, iodine is I2. They are all non-metallic and diatomic molecules. Number 2. Chlorine displaces both bromine and iodine from aqueous solutions of their salts. Now as we move down in the group from fluorine to chlorine, chlorine to bromine, the reactivity decreases. It means that chlorine is more reactive as compared to bromine and chlorine is also more reactive as compared to iodine. So yes, chlorine can displace both bromine and iodine from aqueous solution of their salts. Option 3, the halogens become more reactive on descending group 7 of the periodic table, as we have already studied that down in the group the reactivity decreases. It does not become more reactive, it becomes less reactive. So statement 3 is incorrect, as only option 1 and 2 are correct, therefore answer is B. Question 30. Which two statements indicate that metal M may have a proton number between 21 and 30? Now looking at the periodic table, if we see that the atomic number of scandium is given as 21, while the atomic number of zinc is given as 30. From scandium to zinc, all are transition elements or transition metals. Number 1, it conducts electricity. Now this is true for these elements present from 21 to 30. This is also true statement for all other metals present in the periodic table. So from this option we cannot guarantee that the proton number is between 21 and 30. Though this statement is correct, but it is applicable to all metals, not just transition. We have to find out the properties that are only possible for transition metals. Number 2, it does not react with water. Now this is true for these transition elements, but this is also true for other elements present in the periodic table. So therefore this statement does not define transition metal. Third one is that it forms two basic oxides with the formula MO and M2O3. Now in both these oxides the oxidation state is different. In MO the metal is +2 oxidation state, while in M2O3 the metal is in +3 oxidation states. Now we know that only transition metals can exist in more than one or variable oxidation states, so therefore this statement defines transition metals. Number 4, it forms two colored sulfates. Now this is also true because only transition metals form colored compounds, not other elements present in the periodic table. As option 3 and 4 are correct for transition elements, so therefore answer is D. Question 31. The table gives properties of 4 metals P, Q, R and S. First is the method of extraction, second is the reaction with water, third is reaction with acid. We have to find out which statement is correct. To solve this, we can write the reactivity series. We have potassium, sodium, calcium, magnesium, aluminum. Then we have zinc, iron, tin, lead, and then in the last we have copper, silver and gold. Now we can see as we move down the reactivity decreases. Now it says in the method of extraction that P can only be extracted using electrolysis. Now these first 5 elements are very reactive, so therefore they can only be extracted using electrolysis. So option A says P is the least reactive. This is incorrect because most reactive elements are present on the top, so it should be the most reactive one. Part B, Q would displace R from a solution of its salt. Let's see which one is more reactive, Q or R. Q can be extracted using heating oxide with carbon, while R can only be extracted by electrolysis, so it means R is among these and Q is among these, because these elements they can be extracted by heating with carbon. So we can say that R is more reactive than Q, so therefore Q cannot displace R from a solution. Part C, R could be zinc. Let's see, R can only be extracted using electrolysis, so R is among potassium, sodium, calcium, magnesium, aluminum. It is not zinc. Part D, S could be copper. Let's see, the method of extraction of S is that S can be extracted using heating oxide with carbon. As we know that the elements below aluminum, they can be extracted using carbon. And it contains zinc, iron, tin, lead, copper, silver and gold. So S could be copper. This statement is true. Also, we can confirm S by these properties. The reaction with water, copper does not react with water. And copper also does not react with acid. So among these four, correct option is therefore D. Question 32. Which statements about extracting metals from their ores are correct? Number 1. Aluminum is extracted by the electrolysis of aluminum oxide dissolved in cryolite. This is true statement because cryolite is used to lower the melting point of aluminum oxide, and as aluminum is quite reactive element, so therefore it can only be extracted using electrolysis. Statement 2. Silver is difficult to extract from its ores because of its low reactivity. As we know that this statement is true because silver is less reactive as it is below in the reactivity series of metals. So therefore it is not difficult to extract. It is very easy to extract silver from its ore. Part 3. Iron is extracted from hematite by reduction in blast furnace. This is also true statement as hematite is iron oxide, which is Fe2O3. And in blast furnace different reactions take place and we get iron from this ore. So statement 1 and 3 are correct. Therefore answer is B. Question 33. Which statements about the corrosion of iron are correct? Number 1. Corrosion can be prevented by coating the iron with zinc. This is true and this process is called galvanizing. Galvanizing is coating with zinc and zinc is more reactive than iron, so therefore corrosion of iron will be prevented. Option 2. Corrosion only occurs in the presence of both air and water. This statement is true as both are needed for corrosion. Option 3. Rust is an alloy of iron and oxygen. This is incorrect because rust is not an alloy. It is a chemical compound. Alloy is just a physical mixture. It is not chemical compound. So therefore this statement is incorrect. 4. Sacrificial protection occurs when iron is connected to a less reactive metal. Now this is not true because more reactive metal will sacrifice itself as compared to iron, as that metal will react first as compared to iron. So statement 3 and 4 are incorrect. Only first two are correct. Therefore answer is A. Question 34. In the extraction of aluminum from aluminum oxide, the following three reactions take place. They have given the reactions. One is aluminum plus 3, it forms aluminum metal. Second is oxide, it forms oxygen. Third is graphite, which reacts with oxygen to form carbon dioxide. Which reactions take place at the positive electrode? Now we know that positive electrode is anode and anions always move towards anode. Aluminum plus 3 is cation as it is positively charged, so therefore this will move towards cathode, not anode. Oxygen negative 2 is anion, so it will move towards anode to form oxygen. Third is graphite, as we know that anode is made of graphite. So at higher temperature what happens is that this graphite, which is carbon, it reacts with oxygen formed at the anode to form carbon dioxide. So option 2 and 3 seems to be correct. Answer is therefore D. Question 35, which statements are correct? Option 1, chlorination is used to remove unpleasant taste from drinking water. This statement is incorrect because chlorination is used for disinfection. As chlorine is antimicrobial, so it will remove microbes or bacteria. So statement 1 is wrong. Statement 2, desalination can be achieved using distillation. Desalination means the removal of salt. And distillation is the separation of liquid from solid or liquids from liquids. As salt can be removed by distillation. For example, sodium chloride is dissolved in water and distillation will remove water molecules and salt will be left behind. So therefore this statement is true. Option 3, the presence of phosphates in water and soil encourages plant growth. Now 3 things are needed for plant growth. One is nitrogen, one is phosphorus, one is potassium. So phosphates, it consists of phosphorus, so therefore this statement is true. As statement number 2 and 3 are correct, therefore answer is C. Question 36, 2 isomers are shown. One is this one, we have 4 carbon atoms in the long chain. And second is we have 4 carbon atoms but in branched form. Which statements about these isomers are correct? Number 1, they have the same empirical formula. Let's find the simple ratio of atoms. We have 4 carbon atoms in the first one. We have 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. We can simplify the ratio, so it will come equal to C2H5. So this is the empirical formula of first one. Let's look into the second one. We have 4 carbon atoms, 10 hydrogen atoms. So again the empirical formula is same as the simple ratio comes equal to C2H5. So they have same empirical formula. Option 2, they have different molecular formula. As we can see that the molecular formulas, first one is C4H10. For the second one again it is C4H10. So therefore they do not have different. They have same molecular formula. Part 3, they are members of the same homologous series. Now we can see that this homologous series is from alkanes, as they have single bonds between carbon and carbons. And in this one again we can see that there are single covalent bonds, so this also belongs to alkane. So yes, they are members of the same homologous series. So correct option is therefore B. Question 37. A hydrocarbon compound Q has the molecular formula CXHY. Q reacts with hydrogen to form a single product with molecular formula CXHY plus 2. Which statement about Q is correct? Let's first write the chemical equation. We have CXHY, which is represented as Q plus hydrogen, and these hydrogen atoms are actually added as the formula becomes CXHY plus 2. So this is simply an addition reaction, and we know that the addition of hydrogen, it can take place in alkenes. So if we take this one as alkene, let's suppose it is ethene C2H4, we have double bond between these 2 carbon atoms, plus hydrogen, it will form ethane, which is C2H6. Let's look into the options. Option A, Q does not burn in air. This is incorrect because Q is a hydrocarbon. It contains carbon and hydrogen. It can combust in air to form carbon dioxide and water. Option B, Q is a saturated hydrocarbon. This is incorrect because Q is alkene. It is not alkane. And alkenes are not saturated, they are unsaturated because of the presence of double bonds. Part C, Q reacts with bromine to form a single product with the molecular formula CXHY-1Br. Let's do this one. Q reacts with bromine. So we can take this one as Q. We have 2 carbon atoms, 4 hydrogen atoms. Let's react in this with bromine. What will happen that addition reaction take place and one bromine is added to first carbon, second bromine is added to second carbon, double bond gets converted into single bond. This is the case with all alkenes. So now if formula of this compound is CXHY, where X is 2 because there are 2 carbon atoms, Y is 4 because there are 4 hydrogen atoms, so then the formula of this should be CXHY and 2 bromine are also added, so it should be Br2. So this is incorrect. Part D, Q reacts with steam to form a single product with the molecular formula CXHY plus 2O. Again, we can do similar reaction. We have alkene plus steam. Steam is added. Steam is water, H2O. One part of water it adds to one carbon atom. Second part will be added to second carbon atom. Double bond is converted into single bond. Now we have 3 hydrogen atoms with the first carbon. Double bond is converted into single bond. There are 2 hydrogen atoms on the second carbon and we also have OH bonded. Now if this was CXHY, then this must be CXHY plus 1 as one hydrogen is added and also OH is added. So CXHY plus 1 OH, or overall we can see that 2 hydrogen atoms are added. One is this one is this one. So we can write CXHY plus 2 and one oxygen atom is also added. So this one is correct. Correct option is therefore D. Question 38. Which structural formula represents an alcohol? Now alcohol is the organic compounds that consists of this functional group OH. In these we can see the functional groups. This one is ether functional group, as we have oxygen bridge which connects two alkyl groups. In second one we have OH functional group which is alcohol. In third one again we have oxygen bridge. In fourth one we have C double bond OH which is carboxylic acid. So this one is ether, which is not in the syllabus of O levels. This one is alcohol because of the presence of OH. This one is carboxylic acid. So among these four, only this one is alcohol, all three other are wrong. Therefore answer is B. Question 39. Which statement about carboxylic acids is correct? Number A. They are prepared by the oxidation of alkanes. Now carboxylic acid, they can be formed by oxidation, but not of alkanes. They are formed by the oxidation of alcohols. Part B. They decolorize bromine water. It is not carboxylic acid which decolorizes bromine water. It is actually alkene that can decolorize bromine water by addition reaction. Option C. They react with alcohols to form esters. This is true. As we can see in this reaction, we have CH3OH alcohol plus CH3COOH carboxylic acid. Now both will react and H and OH, it will form water. Rest of the molecule is converted into ester. So we have CH3COOCH3 as product along with H2O. The name is methyl ethanoate. Part D, they react with carbonates to form salt, hydrogen and water. Let's do the reaction. We have carboxylic acids, they are acids, so acid, they react with carbonates to form salt, water and carbon dioxide. We can do an example. We have CH3COOH, this is ethanoic acid, plus if we take sodium carbonate, then the salt formed is CH3COONA, sodium ethanoate, along with H2O and CO2. No hydrogen gas is formed, so therefore this is incorrect. Correct answer is therefore C. Question 40. P is a polymer that has 6 carbon atoms in each of the monomers from which it is formed, is not a polyester, is formed using condensation polymerization. What is the partial structure of P? Let's look into the first option. It must have 6 carbon atoms in each of the monomers. Now we can see we can divide this into 2 monomers. We can divide part B into 2 monomers, C into 2 monomers and D into 2 monomers. Now let's look into the number of carbon atoms. There are 4 carbon atoms in the center, 5 and 6. So there are 6 carbon atoms in one of the monomer and there are 6 carbon atoms in the second monomer. In part B, we can see we have 6 carbon atoms in the center. This one is 7th, this is 8th. So we have 8 carbon atoms in one of the monomer and in second monomer we have 6 carbon atoms. So B is incorrect as both of the monomers must consist of 6 carbon atoms each. In part C, again we can see we have 4 in the center, 2 on the side, so it is 6 carbon monomer. On this side again we have 6 carbon monomer. So it could either be A or C according to the first point. In part D we have 3, then 4, 5 and 6. 6 on one side and 1, 2, 3 and 3, 6 on the other side. Let's look into the second option. It is not a polyester. Now polyester is something that consists of this linkage, which is ester linkage. Let's look into part A. We have ester linkage present. So this A is a polyester, so therefore A is incorrect. In part B, we can see this is not ester, it is amide. Again, in part C, we do not have ester linkage, and in part D, there is just alkane. Third option, it is formed using condensation polymerization. Now we know that when condensation polymerization takes place, then we can have amide linkage or ester linkage. So as ester linkage is incorrect, so it must be amide linkage. In part D, we can see we have long chain of addition polymerization, so therefore this is not condensation polymerization example. So in part C, we have 6 carbon atoms in each monomer. C is not a polyester, it is polyamide, and C is formed using condensation polymerization, so therefore answer is C.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.